Welcome to qnawire.
Okay, we have got 3-methylhexane. So there's our hexane. We've got a methyl on the 3, and we know that it's S-methylhexane. So when I have to draw a specific stereoisomer, I usually just guess, and then if I get the wrong one, I just swap two of the groups because that will change the stereochemistry, right? So let's figure out what the stereochemistry of this is. The highest priority is this longer chain, followed by the second longest chain, followed by the methyl group and the hydrogen. This, if I connect them, is counterclockwise, and the highest priority substituent is in the back. So if we do counterclockwise when the highest priority substituent is in the back, that tells us that we've got S. So I guessed correctly, and we've got the right one. Okay. This is the structure of our S3-methylhexane. Now the question is, what's going to happen if we do radical bromination? So Br2, H-nu for UV radiation. And I guess, the key step, this isn't the whole mechanism, but the key step in this reaction is the following. Got our methyl group here, our wedge to hydrogen here. We've got a bromine. We'll at some point get a radical bromine. And this, let me draw a straight bond, actually. It's carbon-hydrogen bond, selectively the one at the most substituted site, will be abstracted by the bromine. Okay, and the radical will be left behind at the tertiary center. Right, so this is a key intermediate, right? Because what's going to happen is that we're going to get another HBr or another bromine radical at some point that will come in and form a bond. Now, what happened? Why didn't I draw this as a wedge? Well, recall that radicals on carbons are planar, right? It's got a top side and a bottom side, but neither is preferential, right? So we lose the fact that this is a wedge when it becomes radical. We lose all stereochemical information, and in fact, this bromine can effectively add from the top side or the bottom side, right? So side on, bromine can add from the top or the bottom. And so we should get a 50-50 mixture of both R and S. We'll get a racemic mixture of these two.